Yeah, I'm Adriano, and I'm a junior researcher at Sentai, an institute in Turin, and I will talk about efficient streaming sampling methods in Julia. But first, let's define what is the streaming context I'm talking about. Um, an input, we are talking about an input stream which is fed sequentially, and you want to sample from this input stream without storing the population which is this input stream in memory, and just store the sample. This is in general what online algorithms do a synopsis of your stream in one or at worst a few passes. And the advantage of these methods in respect to population methods is that they can work in big data scenarios, because you don't need to store all the population in memory, but just a sample. And also that the sampling process can be stopped at any time, and you will have a sample of the population, even if the population is not all iterated on. And it is even possibly better in an offline setting. I have some benchmarks which show also that. And this is my library is the first actually in all languages, and which implements a large set of these methods. And Julia is especially suited because it allows you to have performance even in this sequential iteration setting, which in vectorization is actually doesn't apply. And the implemented methods are of two categories. The first are reservoir sampling methods, and the second I called the stream sampling methods. The first one, the reservoir methods, are truly one pass. You just iterate on your stream and keep elements if they are decided to be sampled. The memory required is the one of the size of the sample, and I implemented in all cases. There are algorithms for unweighted, weighted, with and without replacement. And instead, stream sampling is still one pass, but you need to know the length, or in the weighted case, the total weight of the stream. And the memory is actually one, because here you just this kind of algorithm acts as a filter of your stream, and so it actually, you can, if you iterate, you get each element at a time with the sampled elements. And this is just a little demonstration. Here, for example, the two main types are reservoir sampler, stream sampler of this library, and you can have you can create those types with a certain algorithm. For example, this is an algorithm for weighted sampling with replacement. Then you can fit some data in these samplers, and in the end, if you have multiple samples, you can even merge them in a unique sample, so that if you, in this case, the sample are composed of two elements, and the merged sample will be composed of two elements, but it will be a sample from the union of the two streams. The same can be done with the stream sampler, but in this case, the iterator should be passed inside the initializer, because in the end, this acts as a filter, as I said before, and you can in the end combine the samples in a unique one, as with the reservoir methods. The performance of these methods are very good when you consider that the population methods actually require you to collect the all population in memory, and if this is accounted for in the benchmark, you will see that all these methods are more than an order of magnitude better than a population, than the population methods. And actually, there are some cases where the reservoir methods can beat the stream methods. The stream one pass here refers to the case where you actually know the length or the total weight of the stream, and so the methods are faster in this case. And so these methods actually are very good, and they can even be used. For example, some application of these methods could be that they can be even more general sample methods in StatsBase, because you could do sampling not just on abstract array but on every iterable object. And I actually use this in agent.jl, which is another library I work on, and for sampling some iterator in this setting. And this can be also used to sample from on-disk data. Since these methods are all sequential, they work well in this case, because SSD or other other disks have much better performance in the sequential case than in the random access case. And also to sample high frequency data, there is an ongoing collaboration where I'm working on with the European Spallation Source Center, where we are sampling real-time data from a simulated neutron detector. And this sample algorithm can be used so that you do then data analysis on the sample and not on the big terabytes of data created by the simulation. And here you can see, for example, the performance on some persistent data, 100 gigabytes of tabular data in a raw format. And you can see that the chunk methods, which actually uses population methods, and on chunks of the population, then you combine the various samples to obtain the final sample with the methods of StreamSampling.jl, is much slower than the other methods. Here, for example, the reservoir method is the fastest, and it's actually maximize the performance of the SSD I worked on, so it could even be better. But my SSD was I had a maximum throughput in reading at 2 point something gigabytes per second, and so that is the performance I got. And so I hope you enjoy, and I'm happy to take questions.